So let's talk about cookies and user authentication. So we have our nice little cookie logo here. There's lots of cool images for cookies. It is a funny name. So we'll talk today about what a cookie is and why it's even called a cookie. And we'll look at what's inside a cookie. Is it code? Is it a file? Is it dangerous? And why do we use cookies at all? We'll do some examples of reading and setting cookies in code, because that's what we're interested in. And then we'll look at making a really simple app to use cookies to save our favorite animal. So when we revisit this website, we can know what animal we like. Okay, and then we're going to talk a bit about user authentication. That is something we'll be doing very shortly here, if we haven't done so already, in the Tiny app, where we have to now authenticate users, log in, register, and then protect some pages to only allow authenticated users to access. And we'll do a little example of that. We'll do a small little single page, protected page. Get started. So first off, what is a cookie? Well, a cookie is a piece of information that is stored in your browser. And it is just like a key value pair. That's all it is. If you Google, and let's try that, let's actually do a search for what is a cookie. And invariably, you get the wrong answer. So what is a cookie? Okay, cookie or text files, wrong. Cookie is a small file, wrong. Oh, small blocks of data. Wikipedia is getting better. Okay. All right, cool. Norton, they're pretty smart. So yeah, okay. Also good. So yes. So, but when you Google or get information on what a cookie is, it will say it's a file. No, it's not a file. It may be a file. It may be saved as a file, but it's not a file. And we'll look about why that's the case. To us as software developer, a cookie is just a key value pair. It's part of an object, key value, key value. It's just one of those entries in an object. It may or may not be saved by the browser as a file. That can happen, but a cookie is not a file. A cookie is just some information that is transmitted from the browser to the server. Why are we using cookies? What's the problem we're trying to solve with cookies? Well, the problem is that HTTP is stateless. I think I have a little slide here. There we go. HTTP is stateless. It does not remember. So when you connect to a server once, the next time you make a request, it has no idea who you were or where you came from. It's a brand new request. It's like that, what's that 50 First Dates movie where somebody can't remember? And that's the case. HTTP does not remember you, has no idea who you are. It's completely stateless. It's a stateless protocol. Every request is a brand new request, which is great. But what if you want to log in and stay logged into the server? That's where cookies come in. We use the example of like a nightclub or some place where you have to pay a cover charge. Maybe you've paid to get in, maybe they checked your ID, let you in, and you had to pay whatever it is, 10, 20 bucks or more, depending on the place. Okay, so now you're in. Well, what if you have to leave? Oh, I got to go to my car. I forgot something. Or I need to go outside for some other reason. Well, you're going to go out. You have to come back in. And the person at the desk, they can't remember you, have no idea who you are. As far as they're concerned, it's the first time they've seen you. So what would they normally do in a situation like that? Anybody been to a nightclub or a bar where you had to pay money and you wanted to leave and come back? What do they normally do? Yeah, pay again. Yeah, exactly. Pay again. Or a hand stamp. That's a great one. Yes, sometimes they will stamp your hand, which I can barely read. I don't know how they read that, but they give you a stamp or some other something like that, that tells them, this person has been authenticated. So when they go in, there's my stamp, come back in again. So the front desk person or the bouncer knows, okay, you've already been authenticated. You've been here before. We know who you are. Go on in. So that's information that's been stamped on your hand. That's a cookie. They stamped your hand. You went and you came back with the same stamp. Yep, go back in. And no further processing required. So that's why we use cookies, to handle this stateless concept of HTTP. Okay, and they are key value pairs. Otherwise, as it says, you'd be logging in every time you wanted to do something. If I'm on my Amazon account, looking at things, checking my prices of stuff, I'd have to log in every single time I wanted to get a new page. That would be very annoying. So cookies and user authentication really go hand in hand together, especially when it comes to websites. I think this slide also says, here we go. So here's an example. Let's say I do a post request. I log in. So I log in and the server sets or changes the response to ask me to set a cookie. Now, when the server does that, it is a request. The server sends back a suggestion that I should set this cookie. It doesn't set a cookie for me because that's on my browser. Cookies are saved only on the browser. Now, the browser may save it as a file. They may save it just as something in memory or in a database or something else. But the server, when it wants you to set a cookie, it will ask, could you please set this cookie? Because that'd be very useful if you want to talk to me again. That's great. It's like the bouncer saying, we probably should stamp your hand because you might want to use that when you come back. You can always say, no, you're not stamping my hand. Forget it. No problem, sir. Have a nice day. You come back in, no stamp, you got to pay again. So you probably want to get that stamp. And the browser probably wants to set that cookie because there's very likely a very good reason that the server asked you to set that cookie. So you will get a response back because once again, HTTP is request and response. A request is sent and the response comes back. This response will contain a request along with your information. Please set this cookie. All subsequent requests, as long as that cookie exists on your browser, will contain that cookie. So if you do another get, cookie comes along. Another get, another post, cookie comes along for the ride again. So every subsequent request will contain that cookie, and it'll contain it more or less unchanged. The word cookie came from the expression magic cookie. It's magic cookie. It refers to a packet of data in computer science, of information that doesn't get changed when it goes back and forth. It stays the same. And that's kind of the same thing with cookies. The server will say, set this cookie. It'll save it, but it won't get changed here. It's expecting to get back the same cookie that it asked you to set. It's like when you get stamped on your hand, the bouncer is going to expect to see the same stamp. If you've doodled on it or maybe changed its color because maybe you didn't like the color green, well, chances are they're going to go well, wait a second. This is not the same stamp I gave you. I'm sorry, I'm not going to accept this. You got to pay again. So not the best idea. So the browser usually does not alter the cookie unless the server has asked it to. But once again, it is still a request. The browser or the client does not have to set that cookie, right? So that's how cookies work. It's things like a shopping cart. When you go shopping on an e-commerce, when you build your shopping cart, that gets built using cookies. It is domain specific, which means cookies are completely tied to that URL or that domain. So if there's a cookie for localhost :8080, then that cookie only exists to localhost :8080 or google.com or yahoo.com or Amazon. That cookie is locked. So no other domain can read that cookie. Only the domain that requested you to set that cookie can read the cookie, which means your browser will not send the cookie to anybody else except the server that sent the request in the first place. So if this server asked you to set a cookie, that's the only server you send that cookie back to and nobody else. That server is the one who will ever see that cookie. So they're pretty secure. That's baked into the browser. All modern browsers have that as a fundamental feature. They will not leak cookies to anybody else. It's just really fundamental. There, of course, cookies are used in ads. Let's say that there's an image on your web page. So if I go to a Google site, there we go. And let's say there's an ad here. Of course, Google never does ads, right? But in case, let's say they had ads right there. Even though I'm on, let's say, some website where I'm getting some information, such as a news site or something, I'd be an ad there. That ad would be from some domain like Google. Well, that little ad might request that I send a cookie, and my browser will set the cookie. Now I go to another website. Maybe it's on some other news site. There's another ad also from Google. Well, guess what? My browser sends that same cookie to that little ad or that URL because it's a request and cookies get sent to the domain where it came from. So now Google knows that, oh, you were on this site before, now you're on this site. We know that now. It's called a tracking cookie, which are getting harder and harder to enforce because browsers are now fighting back against that. Plus you can get extensions. So, and I think Firefox and Chrome pretty much now just disallow tracking cookies. But that was one very imaginative use of cookies, probably one the inventors of the cookie or the internet cookie never thought of. But it was ingenious because now you can track people. This particular type of browser went to these 10 websites in the last 2 days. I can understand the shopping patterns. So it's interesting stuff. That's what cookies are used for, but generally they're used just for the session cookie. Those are called persistent cookies, the ones that stick around. Most cookies, you can program them so they don't survive the session, but some do. And it really depends on the server. The server can say, here's a cookie and it should only survive the session and then it's gone. Or it'll say, I want this to be a persistent cookie. And that's a request that the server will make to you, the browser, that you can either honor or not. Okay. Let's look at an example of a cookie. So I've got little server.js, the world's simplest Express app. Now this should look pretty familiar to everyone. Server.js, require Express, Express port 80, EJS, which I might need, and that's about it. And listen on port 8080. So I'll start this server, node server.js. App is listening on 8080. Okay, and let's open this page. I'm going to go here. So localhost 8080. Cannot get slash. Great, it's perfect. That means I have a server that's listening. Of course, Express's default response is going to be cannot get slash because slash doesn't exist. I would have to make a slash endpoint. Okay, well, that's easy enough. We've done this before. I simply make an endpoint. I go app.get, just like that. There's my app.get. And these two parameters. The endpoint I want is going to be slash, and the function that I want to call when that happens. And this, as always, is request and response, res dot or rec and res, and function there. So there is my endpoint. We normally close it off like this. So this is the common pattern you'll see for an Express endpoint. Okay, and we can just do res response, and we'll just send. Okay, there. See if it works. I'll start and stop my server, which I might forget. And please remind me today if something doesn't work. Say, Gary, you forgot to restart the server. Yeah, that's right. Okay. Okay, refresh this page. I get okay. Fantastic. I've now created my first endpoint and it worked. All right. So let's look at setting a cookie. We're going to have the server request that my browser set a cookie. And to do that, it's relatively simple. You do it before the response. So when you do a send, it's basically over. Once you send a response to the server, you cannot do more things after this. So this has to be done before you send the final response. So I'm going to do it here. I'll say res.cookie. And that is how you set a cookie. The res.cookie function, just like that. And it's a key value pair. So it takes two parameters. Unsurprisingly, the key and the value. So we'll set a cookie. We'll call it test cookie. And we'll send a string. Hello. There. We've set a cookie. Or rather, we're requesting that the client that makes this request will set the cookie. This is not us setting the cookie. This is saying in the response, send along a request. So now let's go to the site and, well, we saw absolutely nothing, did we? Now there's a way to check in your browser if in fact a cookie was set. That is using DevTools, and both Firefox and Chrome have DevTools. You can open that up and it's under, take a look, storage in Firefox and application in Chrome. Let's take a look. Okay, oh, there we go. Got a few cookies. So delete all. Okay, let's run it again. Refresh the page. And there we go. We have a cookie set on localhost 8080. In Chrome, it's the same thing. Let's go to Chrome. We'll do localhost 8080 / go there. And let's look at our DevTools here. Go to here. It's under application. Make it bigger. There we go. It's much bigger. And we have test cookie hello in there. Notice it is saved specific for that domain only and nobody else, only for this domain. Okay. So we have a test cookie. This is great. Now, as you mentioned, this very well might be saved as a file on our browser. I don't know. I'm not sure what Firefox does, what Chrome does. I have no idea. I think Internet Explorer used to save them as files, but I can't quite remember. But it doesn't matter. That's specific to the browser. Let's prove that. We can tell our friends what cookies really are. I'm going to do a curl command. I think I saved it here. There. I'm going to curl my server. I'm going to do a clear screen before just to make sure I clear the screen. So I'm going to curl that URL right there. Okay. Now, anybody see a file get transferred from my server? Maybe I'm not looking closely enough. I don't see any file there. Do you? There is no file. Cookies are files. Okay. This is a request. You get back a request from the server. And look at this. There's the request. Please set this cookie. Set cookie, test cookie equals hello. Please do that. So this is the server responding to me. And this is curl. So curl has no ability to set cookies. So curl ignored that request, didn't do anything. There's no cookie persistence in curl, so it didn't save it. The request again, same thing. Please set the cookie. Okay, so let's verify that. Let's go ahead and now we're going to read a cookie on the next one. So we need to read the cookie. So we set cookies by simply going res.cookie. Easy enough. There's no module required for that. However, to parse a cookie, you do need to use what's called the cookie parser. And it's easy enough. We go const cookie parser equals, I have to require it, cookie dash parser. And now I have the cookie parser loaded in, and I can use that cookie parser, which, as the name suggests, I go app.use, app.use, and it's going to be cookie parser. And that's all you have to add. Once you've added that, you've now added the ability to all your endpoints to parse cookies. Okay, so How would I read a cookie? Well, let's just take a look at cookies. They're in the request now. So it's req dot cookies. Cookies. That's the cookies. So any cookies that you got back or that you got from the browser or the client will end up in this thing called req.cookies. So we can console log that. We'll console log req.cookies to see if we get any cookies back. Okay. Let's start our server. Okay. Let's give it a try. So let's go here. Let's go to this one. And we're going to clear this cookie. Delete all cookies. Okay. All cookies are gone. So we'll hit the page the first time. Restart my server. Okay. And refresh the page. Okay. So the first time I did a get. And it asked that I set a cookie. And look at that. See, we got a cookie back. Okay. So when I request the page again, the cookie's still there. It gets the cookie, and we'll look at my console log now, which is right here. That's the cookie I got back, or I got from the client. So every single request that comes, I get that cookie in my cookies object. Okay, let's try it again. Delete our cookies. There we go. Okay, do a request. There we go. The first time we made the request, you notice we got null. We got nothing back, an empty object. That's because on the first request that this browser made, it didn't have a cookie to send. So cookies was empty. That's just a way of getting an empty cookie. So it's an empty object. So let's have a subsequent get. We do get again. This time, test cookie. So that is how we read cookies. The server will send back the cookie, usually faithfully, that you set. You set a cookie, you're going to get it back. That's generally the contract that have, if it's a first-party cookie, which means it belongs to you. It's not a third-party cookie for somebody else. Your server is sending a request to set a cookie for itself. Please set a cookie for me. And virtually all browsers will honor that request because it's harmless. There's a domain, it's asking me, set the cookie. It's very useful. So they will honor it, and they'll send back every single request with that cookie unchanged. That's why it's called magic cookie. It doesn't change, it's back and forth. Okay. So we can use this. Cookies are great because we can use this feature of cookies to do all kinds of really cool things, like remember what somebody entered. Let's try that. So let's go under our code. Don't need curl anymore. Okay. And let's write ourselves another small app with a page. I'm going to write a little page. So I'm going to call this server.js. Let's make a little file. I do have a blank. Well, here we go. If I clear my cookies and I visit the same, does it save the same cookie into or as new cookie? Chances are it's going to ask to generate a new cookie if you do anything that it hasn't got information for. So that's what happens. It will ask you to set a new cookie. It'll be fresh, a fresh object of cookies, because it probably needs stuff. You can't stop sites from asking for cookies, and they're useful. These may be very useful cookies. You probably don't want to deny them the first-party cookies because they asked you for a reason. Otherwise, the site just might break. It won't work at all. But yeah, if you clear your cookies, you're a fresh face to that website. They have no idea who you are. They've never seen you before. No cookies. So you may even have to do all kinds of stuff. Like in your bank, you may have to do your third-party authentication again. What's your mother's middle name? What city are you born in? What school did you go to? All over again. So, some of those cookies are kind of useful. Let's make ourselves a little app here. We're going to go ahead and we're going to actually make an EJS. We've got EJS here. I've got a blank view here. So I'm going to build a couple of these. So I'm going to make one called home and one called about. So let's just make a view here. Call this one home there. And I'll make one called about. I'm just dragging in there. About. This won't take too long. Now I have two EJSs. Okay, let's make ourselves some endpoints in our server side. We're going to send out these. So there we go. We'll make one called home. Home, and one called about. And in the home, we're probably just going to render that EJS. So we're not going to set a cookie here yet. There. Instead, we're going to res.render, and we'll render our home. Just like that. Okay. Template bars, we don't need them yet, so we'll worry about those later. That's all it's going to do, is just send the home. We'll do the exact same thing with the about endpoint. And about. And it's going to render the about EJS. Okay. And right now, both of these don't do much of anything. They both say new page. So, but it should work. Let me stop and start my server. I will forget that a few times today. So, okay. Let's try it. Let's go to /home. Oh, how about spelling it correctly? Home. New page. Yay. Okay. Let's try to see if about works. About. Oh, it says new page. Okay, let's go change these. Let's say, make our home page say home. We'll give it a title of home page, and we'll call this home. There. Okay, and about. I know everyone's waiting in anticipation what I'm going to call this thing. Well, it's going to be called about page. So no surprise. And to say about. There. Okay. Let's run it. Now this is about. It says about. And if I go to home, it says home. Okay. So now I have two working pages and they're in different pages. Okay. So now let's do the following thing. Let's have our home page. We're going to make this home page about what's your favorite animal. So we'll add some stuff here. Here we go. I'm going to make this there. We're going to have our page remember what our favorite animal is. Okay, so we'll say, make it H4, something small there. And your, oops, come on, your favorite animal is, and we're going to use EJS as a template so we can do this. As we know, percent equals, and then equals again, and we can put a template variable, oops, there, percent again, a template variable inside that. We'll call it animal. So now our template, our EJS, requires that we pass it animal, doesn't it? Otherwise, it's going to crash. And let's do the same thing in our home EJS. There. Okay. Let's stop and start our server. And let's watch what happens if we don't have this animal declared. Anybody seen what happens if we do that? Yes. I think we've all seen that. Not declared. It's like, what is that? Yes. Well, it's kind of telling us. It says, well, look at that. It didn't like animal. That's the line on line 12, and animal is not defined, which is exactly right. In my template bars, I did not provide animal. So each one of these renders needs an object with a key called animal. So animal. Well, and I can just say lizard there, because everyone's favorite animal is, of course, a lizard. Oops, and of course, a comma there. Right. And we'll do the same thing with the home page. Oops, with the home route or the about route, and we'll call it, instead, we'll say it is iguana, which is a type of lizard, I think. Is that right, iguana? Who knows? Okay, stop and start our server. Okay, refresh our page. We are on the home page. Ah, your favorite animal is a lizard. Ah, that's creepy. Okay, let's go to the about page. Your favorite pet animal? Great, about works. So of course, these are all hard coded. So I'm not doing any cookie stuff right now. So now, well, let's make it so we can set a cookie and then subsequent renders of this page will remember our favorite animal, because that's important to us. When we tell them what our animals, they should remember that. So let's go ahead and do that. So here's what I'm going to do. I'm going to, in my home page, I'll make a list of animals. This right here. Let's say span. Choose your favorite animal. I will give them a list. And we'll say li, oops, li. And we'll say, we'll make a bunch of a links. So we'll go a, h, ref equals. And we're going to make another endpoint to set the animals. We have to add that to our server.js in a minute. But for now, it's going to be href equals. It's going to be slash animals slash, and then whatever animal we want to add. So we'll say dog. There. And we'll say dog. Okay, so it's going to print out, click on dog, and it will run our dog endpoint in our server, which will eventually we're going to have that to set to our endpoint. Okay, and it's going to close off our A like that. Okay, and we can copy that a few times. There. Okay, so let's get some favorite animals. So dog, cat. That's like an obvious one. What else do we like? Anybody like some animals? Let's get an animal. How about a ferret? House, yes. Or yeah, the house rhinos or the house hippo. Remember the commercial? The house hippo? Yeah, I love the house hippo. House hippo eats pocket lint. Remember? Is the cute little things? Yeah. So we'll call it hippo because there, hippo. Great. Okay. Because don't want to put spaces in here right now. So hippo. Okay. And a pig. Yes. Pigs are awesome. They're really smart, apparently. Really smart. Great. Okay, so we got a house hippo, a dog, cat. Great. A couple more. Let's do a snake. We all like the snakes game, remember? So snake. We love snakes. Snake. Okay. And how about this? Velociraptor. How do you spell it? Velociraptor. Because we all love the cuddly velociraptor, don't we? They're like our favorite pet. So velociraptor. I'm not going to retype that. Small v. Okay, let's land those. So dog, dog. Oh, cat, cat. That has to be a cat. Okay, cat, cat. Hippo, house hippo. Okay, pig, pig. Snake, snake. And great. Okay. So now if we start and stop our server, if we go to the home page again, look at that. Oh, we got one extra pointy bracket, don't we? Right there. That's a dead giveaway. There, there, there. Let's make this an ordered list too. So we'll say OL like that. There, make it look a little nicer. Okay. There we go. Choose your favorite animal. Ooh, bad grammar. Okay. So dog, cat, house, hippo, pig, snake, or velociraptor. Of course, I'm going to click on one of these. It's not going to work because there is no animals / hippo, is there? Because I haven't coded that in my server. Oh, tarantula. Oh, yeah, we got to add that one. We definitely have to add that one. So tarantula. Yes. Tarantula. Is that spelled right? I think so. Okay, great. Start and stop, refresh the page, and we have 7 animals. Great, okay. But of course, the row's not working, so we can't use it yet. So now we have to go to our server and make this particular link, make it work. We need a /animals/ something, don't we? Okay, let's go add that. That's not terribly difficult. We just have to make a /animals endpoint. So it'll be a get again. So let's just copy that one, and we'll make a /animals and animals / and it's going to take a parameter name, because when I run this thing, I want /hippo, so /name. I'll use that. Okay, and I can actually, maybe I can make the house hippo, make it one word that way. There. Okay, house, or house _ hippo. How's that? Yeah. Okay. Because it deserves a place on our page. All right. So now we have animal /name. Well, I can get the name. That's easy enough. Const name. Oops. Name equals. Well, actually, my EGS is looking for a thing called animal. So let's make that animal instead. Make our life easy. Const animal equals request dot params dot and the name. Right there. Just like that. That should be all we need, except one more thing. We're going to set the cookie to that. So now we're going to set a cookie to the animal. Okay. And we don't want to render here because we're going to have actually a redirect. So let's not render here. Let's instead do a response.cookie. Response.cookie. We'll just set the cookie instead. And we'll send it back to the home and the about page. That's more efficient. So we're going to set the cookie of animal. And we'll give it animal. There. Just like that. So now the cookie is set, or we're requesting that the browser save this animal as animal. And we're going to res.redirect. There. And we'll send them back to home. Back to home. So it'll look like the person just clicked and nothing happened. There'll be a slight flash, but it'll look like really nothing happened. They just picked the animal. Okay. So now we have our get animal's name. We've got the name, animal. I'm going to set the cookie, res.cookie of animal to my animal, and I'm going to redirect back to home again. Okay. Let's start my server and see what happens. Okay. So refresh my page. If I click house hippo, well, it still says your favorite animal is lizard. Why? Well, I didn't change home's EJS. It still says that, but my home did not read the cookie at all. So as far as it's concerned, it's just hard coding lizard, right? But let's look at our browser. Let's look at our cookies to see if in fact something got saved. Animal, house hippo. It did change it. Let's pick cat. Cat. Our favorite animal is a cat. So now our browser is saving this information from our website. So Velociraptor. Yes. Okay. So great. We've now been able to save our favorite animal. And of course, everyone loves the pig and tarantula. Okay. All right. So now we have the cookie saved, but of course it's not being used yet because these two endpoints, the home and about, are doing nothing with that cookie. It's just saying lizard and iguana, which doesn't do us any good. So we need to change those a little bit. Let's go here and we'll get the cookie. We have the cookie parser already required and used. So we know we can get req.cookies and we can read whatever is in req.cookies. So const animal equals, animal equals the request, because now we're getting it from the browser. It's going to be the request dot cookies, and we're going to look for animal. So dot animal. Okay, there. Request dot cookies dot animal. And now I'm just going to render animal, just like that. I'm going to send animal to my render. That's really all I need. And I'll do the same thing with my about page. Read the cookie and then send the animal that's in the cookie to my template. Okay. So hopefully we've done almost everything right. Let's take a look. Okay, start my server. Okay. Now, do I have a cookie? Any cookies? Let's just clear cookies. I think we have probably the last cookie because it is persistent. Yes, we do. We have some cookies saved here. Let's clear all cookies. There. All the look cookies are now cleared. So I'll go to my web page here, refresh the page. Is blank because no cookie was set the first time. And we didn't save a cookie, so we need to pick a cookie. Well, we know this works now, don't we? Let's go with the house hippo. Click on house hippo and save that. It did a redirect back to home, and my favorite animal is indeed a house hippo. This is working. That's great. If I refresh the page, it's still a house hippo. That's really great. So it is now reading the cookie. Every time you go to this page now, even if I, see if I close my browser, maybe not, because I may have cookies being disabled when I refresh browsers. Let's take a look. Let's take a look. Nope, it remembered. I closed my browser and it still remembered a house hippo. So great. So really, a house hippo is it for me. Okay. Let's go to the about page. Now, the about page really didn't do any setting of cookies, but it's the same domain, localhost 8080. So it should also have access to that cookie. And it does, a house hippo. Okay, set it to a velociraptor. If we go to about, it is a velociraptor. This is awesome. So it is relatively simple to set and read cookies in your Express app. When you want to set a cookie, you go res.cookie and you give it a name and a value. It's a key value pair. When you want to read a cookie, you need to have the cookie parser. It's funny, you don't need to have the cookie parser to set a cookie, but you need cookie parser to read a cookie. It's just one of those things. And then to read the cookie, it is req.cookies. And then whatever the name is that you want. Okay. Or you can console log all cookies once again, and you get the whole cookie object. Let's take a quick break and we'll come back in a bit. Let's see. Let me put a little timer. I'll put a 10-minute timer. So we'll come back in about 10 minutes and we'll talk some more about cookies, but more specifically on how they relate to user authentication. Oh, okay. It looks like, so we'll need a few routes. We'll need get/protected and we'll need get/login. Okay, so we'll need that. We'll probably also need get/register. We want to register a user. So /register. Okay. And we'll also need probably a maybe a logout. Yeah, let's do a logout page as well. So, okay. So a login page and a logout page. So a get/. Log out. So we need these things. Okay, so we have a logout. We'll need a login, logout, and a register page, and then a page for our protected path, which is what we really care about, the page that we're actually protecting. Okay, so let's go ahead and work on some of these. The first thing we'll do, let's work on maybe the register page, because that's where everything starts. And at the same time, work on the login page, because they're kind of the same. They're really just going to have a username and password as part of the form. So let's make a page here, and we'll copy our new page there, and we'll call this the login.ejs there. Okay, and in our login.ejs, we'll just put a form. So I'll say the title is login. All right, and login. Okay. I'll make these H2s, which are smaller than H1s. Okay. And all I need to do is I need to have a form. It's going to be a form there. And the two things you need for a form are you need an action. What to happen when the person presses submit. So we need action. So in this case, we're going to have action equals /login. Now, very important, we would not put http://localhost 8080, would we? No. It's going to be just /login. What that will do is the server will assume that it wants the same one. The browser will send along or append the domain to that. So even though it says /login here, your browser is smart enough to know, he probably meant http://8080/login, and that's what will end up at the server. So you would never put a hard-coded absolute URL in your form, or very, very seldom you do that. Okay, so we have an action and we need a method. Now you can leave method empty, but the default method for a form is a get. And we don't really want that. We want to have a post, because that's we normally use for a form is a post. So method equals, and here's the choices, get or a post. It's going to be a post. Great. So now we have a form that's a post that will send its data to /login. Okay. And let's make like a label. Labels are cool. This is HTML4, really cool. We'll say a label and we'll call it email address. So just make a label. So we'll say email address there. Okay. And then we'll have an input. So input. And we'll say name. We don't need type, but it defaults to text, so I don't care about that. But we do need name. Every input needs to have a name. If you want this input to be sent in the post, it's got to have a name. Any other attribute, class or ID, anything else is optional, but it has to have a name. Otherwise, your post will not get sent. And in your Tiny app, you may notice, oh, how come I'm not getting anything back in my form when I submit? Well, maybe your input didn't have a name. So it needs to have a name. Okay. And that's really all we need here. Okay. Now, the next thing I'll do, make another label. And this is going to be just my password. It's like that. And I'll have another input, and I'll just duplicate this one because that's easy. Oops, and a bit extra typing. There. And has anybody now learned those cool tricks of moving stuff around in VS Code like this? Look at that. See? Oh, there it goes. Who hasn't learned this trick yet? Anybody? It's extremely useful in VS Code. Okay. I believe it's Option up on a Mac, or other codes, depending on what you're using. Mine is Alt up on my Windows, but that's because I programmed it. Yes, it's very useful. You go under File, and look under preferences and keyboard shortcuts. Look at this. And move line up, move line down. In my case, I just happen to have that set as Alt up arrow and Alt down arrow. Yours may be set to Option up arrow, Option down arrow, or something else. In Linux, I think you get nothing. It's weird, like nothing's by default. So very useful keystroke. Look at that. It's awesome. They're so useful. Combine it with another very useful one, which is duplicate line. There, and then move it. Look at that. My two most useful keys on my keyboard. Duplicate and move them down. So I just wanted that one. I'm going to duplicate that and move it down. There. Saved me a whole bunch of typing. This is awesome. So that is copy line shortcuts. I believe it's copy line up. There we go. I made mine Alt equal. I think it's like Shift Alt down arrow, but that was way too many keys for me. That is like so popular. I made it Alt equal. You can make it Option equal or leave it the way it is, but it's like 3 keys. Forget it. I use that so much. I made it 2 keys, Alt equal. I'd make it 1 key if I can get away with it. I would make it my equal button if I could. But of course, my equal button is used for making equal signs, so it looks like I can't make it 1 key. So, okay, 2 keys. So Alt equal for me, it can be anything you want. Extremely useful shortcut. Okay, there's our login. And this is going to be name equals password. Just like that. And there's a form. The only thing we need in our form now is simply a button to let them submit their information. And that is a button. And you can say type equals submit. However, the default type of a button, it is submit, turns out. But it's a good idea to put that there, just so to make it clear, this is a submit button. I'm going to have a text that says login. Great. So now I have a login page that when I click submit, it should send the information to /login. At the very end, I'm going to put a little note here. Just say I'll say not registered. Come on. There. I'll just say go here. Make a link. href equals and then /register. There. And a register here. Okay. So now we have a page for our login. Let's get our server to render that page. So we need /login route. So we can copy one of these. These are easy enough. There. Okay. It's going to be get /login. Let's give it a try. So apt-get /login. Okay. Now it's not going to set animal cookies. It's not, but it is going to render the login page. The login EJS. Okay. So I don't need animal. So don't even that. There. Okay. So my get login now renders the login page. Okay. And doesn't need to do anything else yet, really. It's just going to render that page and nothing else. Okay. Okay, so let's test this out to make sure it does in fact work with my page. So let's stop my server, start it again. Anything crash on me? Oh, nothing yet. Okay, it's always a good sign. Okay, so let's test /login and see if I do get a page. Okay, it's a little scary, but it's kind of working. Wow, maybe it's just too big. Hold on. Yeah, maybe I should put some divs in there. What do you think? Maybe I should, or just a BR. BR is really bad practice, but we're going to do that because, well, we will. So let's put a BR in there. BR, like that. And we'll self-close the BR, just separate it lane. This is not the best formatting. Okay. Let's try it again. Okay, what's a little better? I'll put a BR after that login as well. Wow, good thing I'm not getting points for web design. Okay. There we go. Okay, well, it's okay. It's not great, but it's not terrible either. So, okay. Maybe I'll say your password. Even them out. This is really bad design. Your password? Let's try that. Okay, passable. You think so? Okay. All right. Email password. And it's going to do a post. If I click login, well, cannot post /login. So that sounds like something I should do pretty soon. Okay, so I have a login page. I also can make a register page. So let's go ahead and do that. A register page is going to look an awful lot like a login page. It's almost identical. It'll just say register as opposed to login. But for the most part, it's the same page. And in your Tiny app, it's pretty much the same page, isn't it? Let's make ourselves a login page. Let me copy my register page. Let's copy my login page right there. And I'll call it register. There. And the only real difference is going to be the title, just be register. And the body is going to say register. And it's going to post to no surprise, register. Right there in my post. Register. Okay. And so already registered, you should go to login instead. There. Just for convenience. Okay, and login here. And that's about it. It should look about the same. Let's make ourselves a server out to send out that page. Well, that's easy, isn't it? These are easy, they're just gets. So register and ready to register. That's it. Super simple. Okay. All right. So we have 2 of our 5 routes done already. And they're pretty easy. In fact, this is going to be a post, isn't it? That's going to be a post. And we also need a post for that there. And we need a post login too. There, got a few more to do. Post login. Okay. That, and put them in this order. So now we need something to accept the information from these pages. Okay, let's first test our register page, make sure it works. Okay, refresh our page, click on this. Back and forth. I have a working web page that changes pages. Oh, bad spelling there. Let's fix that. Not registered there. Okay, anyway, but apart from that, it looks like it's doing its thing. Okay. So now I need to have something that will register a user for me, okay? Or let me log in a user. Why don't we do a login path first? So in order for a user to log in, we need to have a database of users, don't we? And we've done that in our Tiny app. That's one of the next exercises, is to have a database, in this case, an object that lets us save users. So let's make this object right here. Let's go make a const, call it users. Make an object. And this object is going to contain all of our logged in users, or all of our users that can log in. And I'm going to make a few of them. They're going to be key value pairs. So let's give it some keys, just random keys. I don't know, A123, not the world's best key, but it's just a key. We don't use it in the app other than simply to reference the user. And that's going to be an object. There, I have one user. We'll give them an ID, which is going to be the same thing, which is going to be A123. We'll give them a name, which is going to be, or an email rather, give them an email there, which is going to be, what should be an email? 123 @for.com. It's pretty lazy, isn't it? So, okay. And a password of 123. Super lazy. Okay. So now I have an object. And by the way, I can make it look like this, just to make it look nice. Just like that. There. To make it clear that this is a user object in my user database. And my user's database is an object of objects. So inside my user's object, I have other objects that have key. This is user A123, and there is the user. This is duplicated both ways, and that'll we'll make that clear a little later why we do that. But it's a common pattern you'll see, having the ID in the object and also keyed by that ID. Now I have the user, so now I can build a post for a login. Let's make a login post. Okay. So post login, we need a post route. So it looks a little bit like a get route. Look at that. You can duplicate more than one line. If I highlight things and hit my, in this case, my duplicate key, it duplicates a bunch of lines, not just one. Got to mark that down. Yes, save this in your sticky notes. That is a very, very useful keystroke. Duplicate whatever you want to duplicate. If it's the current line, the current line. But if it's a bunch of stuff, it'll duplicate anything you highlight. Really awesome. This is going to be a post login. So it's going to be app.post for my login. And login. Okay. Now, I want to be able to read the post. Now, right now, this app is not set up to read the body of any posts. Now, you may notice, I'm not sure if they changed this or not in Compass, they have this thing called the body parser, which looks an awful lot like the cookie parser. And we can use that, but if you do use that, you may notice there's a big line through it that says this is deprecated. There is actually a better way to do it now, and it's built into Express 4. We no longer need to require a module. We can simply use something built in to Express. And it looks like this, app.use. It's a function. And we're going to use Express dot URL encoded, just like that. And that is a function that takes some parameters, or takes an object, and we'll say extended equals false. So just some basic stuff. Extended false. There. So this one line replaces the require body parser and use body parser. So this is the new way of enabling URL encoded. What's URL encoded, you ask? I'm glad you asked that. That is a Postma form. So when you post from a browser, you click post, it sends the information as URL encoded. That's how it works. Let's make sure our service still starts. No typos. Great, it all worked. So this is the new way. And this is the way we recommend you do it. If you do have that in Compass, it is perfectly safe to replace that body parser with that line. It should give you the same thing. And what you end up with when you do a post is the following thing. So let's, instead of render register, let's just res.end for now. Or send, we'll send OK. It's kind of our go-to. We're testing out a route. Okay. And the post data is available to you in the request in a thing called req.body. req.body is where the body of that post will exist. Let's console log that. So console log req.body to see if in fact we got a body, and then we'll send back OK. Otherwise, if we don't send anything, our page will just look like it's going to hang. So we have to send something. I'm just sending an OK. Okay, so let's start and stop. And now let's go to our register page or a login page. So go to login. Okay. And now we post the login. Let's try it. I'm going to send 123 @for.com and 123 as the password. Let's make it a little bigger. There we go. Click login. Okay. We got OK. Great. And oh yeah, look at that. We did in fact get our body. Look what it sent. It sent an object that looks exactly like what we're expected. Email and password equal to our password. So we got that as body. So once we have this, we know we're laughing now. We can carry on and do this. So let's check what's going on here. What we probably should do is validate, is this a user? And we could redirect to the page, but well, we don't know who this user is. Maybe they sent a bad username password. Maybe user doesn't even exist, or maybe they do exist and they don't even have the right password. So we should probably do some verification of this user, shouldn't we? So let's do a few things. Let's go ahead and grab the email and the password. So we know that works. We can comment that for now. Let's go grab the email equals, and it's going to be req.body dot, and who wants to guess what it's going to be? Dot, well, what did we send? We sent name equals email. So it's going to be dot email. And the password is going to be dot password. Like that. Well, now we have the email and the password. Now we need to find out, well, does this user exist? Are they even a valid user? So I can check my database, but maybe they didn't send me anything at all. So I should probably check for that, shouldn't I? Let's check. So maybe I'm going to simply right away check if there isn't even an email and password. They're both blank. I got nothing. They just clicked blank email and password. Well, I want to catch that. So we could do that. Now, how can we tell if a string is empty? Let's take a vote on what the best way to determine if a string is empty. Let's see some votes in the chat. How can I get email? Not email, null. What else? Anything else? How can I tell if a string is empty? Not email, if not string, yeah. Great answers, yes, great. We could, of course, do if not email length equals 0, email dot length, or equals 0. That's kind of the longest possible way to do it, but that works, sure. Or we can go if not email length, because we know that 0 is a falsy value, also works. But as is being correctly pointed out in the chat, why not just go to if not email? Because an empty string is also a falsy. In fact, an empty email or undefined email or null email are all falsy. So not email is a great choice because it covers all those situations. So if there is no email at all, maybe there's something totally missing. This was undefined. Maybe it was posted from another website and these didn't exist. This will catch it too. So if not email or not password. So now I'm going to handle the case where nothing was sent. Now you notice I'm doing the if not pattern. This is a filter. What we really want to do is we only want to handle emails and passwords that exist where the user exists and have the right password. So I could have said, yes, if email and password's there and it's the right email and it's the right password, then do what I want. But I'm doing the reverse because that would be a lot of else's, wouldn't it? I'd have to go, if it's right username, do this, else error. Well, I think I mentioned in Slack a while ago that sometimes you should check for what you don't want. Instead of what you are looking for, what you want, I want a good email password, let's check for what I don't want. It's called a filter. Very common pattern. And as we all know, I'm not a big fan of else's, and you should be able to do all this code with not one else in the entire code. There is no else in this entire server.js anywhere. So if there is not an email or password, well, maybe I'll just res. And let's do a res.status. I'm going to return some kind of error. And I'll send a status of 400, which is like a catch-all. You entered something wrong. Remember we talked about earlier the different status codes that you can send, and there's like a whole ton of HTTP statuses. Anybody remember some of those? Who remembers the statuses of HTTP? Anybody? Anybody? Yeah, 200 is good. Yes, 200 is good. 300, yeah, less commonly used. That's more of a redirect ones. Yes, and there's 400, which means bad. 404, yeah. Who hasn't seen 404 not found in their life? Like it's like all the time. Yeah, so 404 and 302 are very commonly used. HTTP status codes. There we go. Status response codes. I love this. Okay. So you have your choice. Now, 100's not commonly used, right? 200's great. Things went well. 200's great. 4 means like, yes, it's good. And we didn't send anything back. Very common. You might see this one quite often. Like, hey, what you did, that was a good thing. And we don't need to send you a response because like, yeah, it's good. We have nothing to say. Very useful one. Okay. The 300's, these ones. Wow. Very cool. Client response methods. There we go. Okay, we get down to my favorite. It's 418, by the way. My favorite status. I'm a teapot. Okay, I'm a teapot. But a 404 is kind of a not found, but a 400 is a just bad request, just a generally bad request. It's a very good one to use for an error. So we'll send a 400. And we'll send back some text as well. We'll say 400, we'll say send. And we'll send the string. Email and password can't be blank there, like that. Can't, and ooh, let's use a double quote. Quoting conflict. There we go, and that works. So we're going to send that back, but we haven't quite finished yet. We're doing this, but we're sending a status and a send. But what's going to happen? It's not going to end there. It's going to carry on and try to send some more stuff. We want things to end right there. So how can we get this to end right away? What can we do? What can we do to simply stop everything? We've done send a status. What can we possibly do? We can do a return. Exactly, a return. Return. We're done. Bad password. Let's just get out of here. There's no point in continuing. Now you might see the return on a separate line, or you could do this. You could just put the return right in front. It's like that. If you wanted to, be really cool. Since the return value is not even read by app.post, it doesn't care. So you could go return that. It doesn't matter. So whichever you prefer, either this or there. And someone said res.end. Well, res.end ends the actual request, but does not stop JavaScript, does it? So if I had res.end here, JavaScript is still going to carry on. I didn't tell JavaScript to end. I simply told Express to terminate your session with that client. So res.end is a very good one. We could have said end as well here. Also would work, but JavaScript, because this is at the end of the day still just JavaScript, it will continue on. I need to have a return, which is why I have a return right there. Okay, so let's just start our server, and we're going to send ourselves a blank email and password. See what happens. It worked. Look at that. I got the message, email and password can't be blank. Let's look at our response we got. We can actually look at our network right there, and I'll do it again. Look at that. And I got a 400, right? That's the fave icon. But my login returned a 400, which is error, okay? Okay. So far, so good. So this is working. So my first check is working. Something else. What if we don't, what is default error? Well, there isn't really a default error. There's a default status, which is 200. So 200 is the status. Or if you don't put res.status, once again, the default status is a 200, which is good, which means Saul Good. Like Saul Goodman. Anyone watch Better Call Saul? Great show. So yeah, Saul Goodman. So yeah, 200 means Saul Good. So we should give it some status, which tells the server or the client, hey, you sent a bad request, I didn't like it. Okay. So now I know I've got an email and password, but I don't know if this is a good email and password. Now I need to find this email. Does this email exist? So I'll go ahead and send my email again, which was it 123 at 4.com. There, right there. And 123. All right. But it doesn't know that it's the right password. Let's click login. And sure enough, it got okay. But it didn't check. So the next thing our login should do is to check, is this actually a good email and password? Well, we need to get to see if it exists. We're going to look in our user database. And our user database is keyed by ID. It's not keyed by email. Oh, it's a bit inconvenient. Otherwise, I could just go const user equals users email. That'd be convenient, wouldn't it? But I can't, because it's not keyed by email, it's keyed by ID, and I have no idea what the ID is. So I need to find this user in my users object. And that sounds like a really good job for a helper function. So I should make one, make a function. I'm going to call it get user by email, which, as the name suggests, will get the user by email. Okay, so I'm going to give it email because it's get user by email, and it's going to return the user. So I need to look through this object. Now, this is something that's not commonly done, but occasionally we have to do it. Occasionally we do have to iterate over objects. It is quite rare. Objects are made for looking stuff up with, users bracket email, users bracket ID. But sometimes you do have to go through an object and iterate it. It's not, the most pleasant task. It's not bad, but it's not really something I do very often. Here we have no choice. We have to use a for in, because that is how we iterate an object. Now we could admittedly get object.keys, but we'll just do a for in because we have a very small object here. So we'll do for in. So we're going to do a for in. Okay. So for in. Look at that. Oh, I even have a VS Code template. I'll type by hand. But VS Code has all these Emmet things. You go for in, you can pick it. ID in users. So I'm iterating the IDs of the users because a for in iterates the keys. And these are all the IDs. So for ID in users. And for every user, I'm going to get the user. So we'll get the user. So const user. Const user equals. And we're going to get it from our users database, users bracket ID. Now we have the user object. Great. Well, now we have the user object, and that user object does have email and password. So all I'll do is I'm going to check, do I have the one I want? Good, there could be 1,000 of them, but eventually I might come to the one that does have that email. So if my user.email equals the email that I passed as a parameter. So if they match, what should I do? What can I do? Well, the function says get user by email, doesn't it? I could say return true. Oops. I could do that, but really it's not return, logical Boolean true false by email. It's get user by email. So return the user. There, just return the whole user. I might need the whole thing. So you might be tempted to write a function that says, does user exist already, and return true false. But in actual fact, I might need more information from that user. I'm going to return the whole user. And an object is still truthy, so it's still technically a true false. It just has more information. Okay. If I've gone through all my users and that email didn't match, I'm going to return null. Now, you're quite correct. I could have returned nothing, which is undefined. That'd work too. They both work. I'm going to explicitly return null, just so it makes it obvious that I'm returning a null object, because null really means no object, whereas undefined means really slightly different thing, means couldn't find it at all, or you're asking if something doesn't exist. In this case, you're getting a null object, so slightly different sense. Do they both work? Yes, they both work. now I have a function called get user by email. I can use that. Let's go to my login post right here. Now I can say, well, does the user exist? Okay. Oops. Let's try that. Oops, my server right there. Let's try it. So I'm going to get the users. Let's have the user. We'll const. Instead of user's email, we're going to call our get users or get user by email function. Get, and we do have a function with email. So it's almost as easy as doing users bracket email because I have a helper function. So user. So one of two things is going to happen, isn't it? Either I'm going to have a user object in user, or I'm going to have null. Okay. So once again, let's check for the situation I don't want. Let's check for null. So if not user, there is no user. So, or there is no user matching that email. I should probably return another res status. Let's just conveniently copy this line, since that's easy. And we'll return a 400. Well, what's a bad user? I suppose doesn't exist. Maybe one of the 300s. Let's look at our codes again. Because really, this is a user couldn't be found this time, not doesn't blank. So email does not exist. And what's a good code? Let's take a look. We can send. Once again, we'll go to our HTTP status codes. Status codes. And this is a source of great debate amongst developers as to what code should I use? There's this endless debates and discussions on teams, like what code is appropriate for this particular thing. We're not going to spend that much time. Probably going to be an authentication thing. So it's going to be a 400, probably. And let's see, unauthorized. Yeah, that makes sense. Maybe it's unauthorized because they're really not. It doesn't exist. Yeah, 401, unauthorized. I like that one. Okay, oops, wrong one. This one. Okay, so if there's no user, which means no user matching that email, we'll status 401 and email doesn't exist. Let's take a look and see what happened here. Okay, let's see what happens. I'm going to send the good email. Okay, great. Let's send the blank email. Great. Let's send a email that does not exist. 1, 2, 3, 4. Let's try that. Doesn't exist. Okay. Yes, some status will actually trigger the browser to pop up a window and ask for basic auth. We're not sending basic auth along with it, so we're fine. So here are 4 ones. Okay. So not authorized. Okay. So that's great. Email does not exist. Let's do something else. How about if not user, or if user password dot password is not equal to the password that they gave us. So they gave us the wrong password. It is the correct user, but it's the wrong password. So now we'll say bad password. There, hacker. Yeah, bad password, hacker. Okay, too bad. Okay, so now the password doesn't match. So if you go start and stop our server, if we now send our 123, which we know is a good email, but we send 1234 as the password. Let's try that. I should get a status with a bad password. Bad password, hacker. Yes, okay, all right. So we're filtering out all the conditions we don't want. Missing email password, bad user, bad email, bad password. So now we're all the way to the end. This is great. So now we know by the time we get to line 60, we've filtered out all the bad stuff. We know we've got a good user. This user exists and he's valid. Okay, well, we can show him our data. So we can go res.redirect to our page. And we'll send to our protected page. /protected. Okay, won't do that yet. We'll just send the OK for now, but that's what we'll do. So let's try this. So we should get OK now, one more time. So 1, 2, 3, 4, 1, 2, 3, we should get OK. Great. Let's do one more thing. Now, if we have a logged in user, let's save that information because we've already authenticated them once. They've already paid their cover charge at the bar. We should probably stamp them that they are authenticated, and the next time you see them, we don't need to ask them all this information. So res.cookie. So this is where the res.cookie comes in. Once you've authenticated your user, you know that email password is correct, user exists, you can save a cookie and you can call it anything you want. In this case, I'll save it as the user ID. Oops, I'll call the key user ID and I'll save the user.id. You notice I'm not going to save the password or the email. I'm just sending the ID. That way, I'm not saving anything really that confidential or sensitive to my cookie, just an ID. It's just a number. And it could be a random generated number, so it's not that important. I'm going to send or save that as my cookie. Okay, so now when the user logs in, I'll authenticate them and I'll save or I'll use the cookie. I'll save the cookie. Okay, start and stop. We'll try it. Now let's watch what happens. Let's look at our cookies when we're here. Okay. And storage, there we go. We'll delete item. Oops, wrong one. Delete all. Now let's log in. So we're going to log into our site with 123@4.com, password 123, and it saved our user ID. Great. So now we know we have a user ID saved. Okay. And that's it. Okay. Later on, we'll redirect to our protected page. So one more thing we'll do. Let's do the register page. So the last step is to handle the post for the register, which is slightly different, but very similar to our login. Okay. So let's make a post for register. And this is going to look kind of the same. So we'll copy all of this. So we'll go Alt equal. I love this key. Alt equal. Look at that. And there's our post for register. Okay. Register. It's going to start off the same, isn't it? Email password, sure. Can't be blank. Yeah, that's fine too. So these are all going to be the same thing. But here's where it gets different. Now I'm registering the user. So now I have my register. Okay. What I want to have happen is, I don't care what the user is. I just want to know, is there a user? I don't care what password they have because I'm not going to check the password. I'm going to check if they gave me one. I just want to know, is there a user with that email? Because I don't want to create a duplicate user, do I? So I want to give them an error. If they give me a duplicate, I'll probably say, hey, wait a second, that's already registered. You shouldn't do that again. So what I can do is now get user by email. Great. That's a great reusable function. So now I'll either have a user or I won't. Well, now, what do I not want? Well, instead of not wanting no user, I actually want to have no user. I want there to be no user found. So if I do find a user, that means that email existed already. So that should be probably a 400 here. Email already exists. You can't use that email and return. Great. So user email already exists. Okay. Or already in use. Okay. Yeah, already in use is better. Okay. Now I'm here. I've got past these two filters. I checked if they gave me bad information and I checked emails not in use. I can now go ahead and add that user. Now what I need a random ID. So const ID. And I believe in TinyApp, they get you to write a little function to generate a random ID. I'm going to just paste in a really terrible ID generator, which is this. Really not a great one. Just a bunch of numbers. So it's going to give you a number between 1 and 1,000. That's it. Okay. But it works as a key. Okay. So there's a random ID. And I'm going to add this user to my users database. And know about objects, since users is just an object, I can say users bracket ID equals a new user. Well, a new user is a new object with ID, comma, email, comma, password. Notice I'm using the shortcut, equals of creating an object because the names are the same. So there's a reason I call these things email, password, and ID, because I can make my object just that way. Now I have in fact saved that user to the database. That is how you create a new key value pair. You just say users ID equals new thing. It's extremely easy in objects. Okay, this is why we're using the ID as the key, by the way, too, because we can then save it. Okay. Well, now I can probably set the cookie with my user ID because I've already logged in, but let's not do that. Let's wait for the login. So we'll just undo that, or we'll comment that for now. What we'll do though is now we've registered the user, we're going to send them back to the login. I mean, ideally, they've registered, we know who they are, but we're going to send them to login so they can go ahead and log in. There. But we're not going to set a cookie yet. And let's make sure we clear all of our cookies here. There. Delete all. Okay, no cookies set. Okay. So there is our register. And we can't do a send after redirect. Register. Okay. So now we have a register checking out password. It's going to add a new user to our database. Let's try it. So stop and start. Okay. Okay. Register. Let's try it. Let's try and register with our existing name. 1, 2, 3. See what happens. Oh, great. Email already in use. It passed. Okay. And on line 77, do we need to compare it? Well, no, not really. If you think about it, this is a register page. All we care is if did any user exist at all with that email. And if we look at our get user by email function, it will return either a truthy or a falsy value. Null is falsy. So if it didn't find that email, that's good. That means we can use that email. If it did find the email, it'll return an object with which we know is truthy, which is a true value. So if I go if user, right there, that means this user existed. So that's, in this case, that's an error. Okay, that worked. So I log in, email in use, didn't continue. Okay, let's give it the blank case. Okay. Oh, can't be blank. That's great. Okay. Let's give it a new one now. 1, 2, 3, 4. Yes. Okay. The password of 1, 2, 3. Let's see if this works. 1, 2, 3, 4 at 4.com. That should not exist. We should be able to register that user. And we did. Look at that. Didn't set a cookie because we didn't ask it to. So no cookie set. Okay. Now we can log in. Let's go ahead and log in as 1, 2, 3, 4 at 4.com and password 1, 2, 3. And that user passed. So great. We have all the plumbing in place for our website. Let's go and quickly change our login because now our login is simply saying, okay, let's make our login now send us to our protected page. Great. And by the way, let's have one more thing. Let's make a protected route. This one. Where is it protected? Do we have this already? Where is protected? I think we have this. Nope, not yet. We've got to make our protected route. We've got to actually send the protected page to the user. And that's easy enough. We're just going to make it, that's a get. So let's go ahead and just do a get on that. We'll copy one of our gets here. There. We'll call it protected. Protected. Okay. And we're simply going to render our protected page. Just like that. And what we need to do is need to have this page check. So this page first has to check. This user is trying to access this page. Maybe we should check if they have a cookie. That's a good idea. So let's get the cookie. Const user ID equals req.cookies. Dot. Well, we saved it as user ID, so it's going to be user ID. So before anyone can access this page, it's going to check, do you have access? Do you have a cookie? Okay. So if they haven't got a user ID, well, maybe they can't be here. So if not user ID, not user ID. So there is no user ID at all. Well, grab one of our errors. They're kind of useful. Where's all our errors go? It's in our posts. There. There. We'll send them. This really is a 401. You can't come. You can't be here. 401 and not allowed. There. You're not allowed to be here. Okay. 403. We could. We try 403 too. See what response we get. Okay. Let's try 403. Once again, sometimes you get funny response from browsers, some of these 400s, but we'll try it. Okay. 403, not allowed. Okay. So no user ID. Let's check. Well, maybe they had a cookie, but anybody can make a cookie, right? Like I can make a cookie. We can create a cookie. I can actually go to my browser and I can create a new cookie, can't I? If I had no cookie, I can create a cookie. Like just make a new cookie right in my browser or with anything. So maybe they could fake their cookie. So I'm going to say, well, is that a real cookie for a real user? So we have the user ID. We can get the user with that ID. And now we truly can go users bracket user ID like that. And if the user wasn't found, if not user. So even though they had a cookie, that user wasn't in our database. It was an old cookie or something. We're just going to say the same thing. Ha. Nice try. Try. Exclamation mark. Yes. Yeah. Sorry. You tried to fake it out, but no, we checked your cookie and it came up wanting. So, okay. So now we check the user. If they're in our database, and it's going to be either this case A123 or whatever one we add. Okay, let's try it. And if it all passes, we're going to render that protected URL. Okay. And let's actually send the user along with it, because I think the protected page needs the user object, just like that. Okay. Let's take a look. So we'll start and stop our server. A lot of moving parts, isn't there? Doing user authentication, there's a lot of moving parts. So we kind of get everything right. The register page, login, redirects. But this is kind of a complete working set for user auth. Okay. So in fact, why don't we, the login page. Okay. So login 1, 2, 3, 4 doesn't exist. Okay. Protected. See if I can get the protected page. Protected. Oh, all protected. Protected. Not allowed. Okay, so I'm not allowed. This page is protecting itself. The page has been wrapped in some protection. Okay. Well, let's try something else. We know that our login is going to send us now. Where's our get login? Where's our post login? Right there. Right. Our login is now going to send us to protected after it sets the cookie. So if things work correctly, a login should send us to protected with a cookie. When we get to protected, it's gonna check our cookie. It's gonna check the user, and hopefully, if all passes, we're gonna get our protected page. Let's give that a try. So we know that 1, 2, 3 is a valid one. Okay, let's try our log in and see what happens. Wow, it all worked. Okay, so I was in there. Fantastic. Okay, great. Okay, so this is a protected page, and as you can see, it is a very valuable page. We would definitely want to protect this against hackers. So it's a pot of gold. Okay, so that's really a discussion on cookies and user authentication. They really go hand in hand. User authentication is a very common use of cookies. It's something you want to know a lot about because it's something we use in our tiny app. Very common. We'll use it in websites all the time that do authentication this way. Okay. Any questions on this? All right, everyone.